All right, welcome. We all feel time ticking away, right? But what is it really? Today, we're going to dive into a pretty wild new idea, one that says time isn't some fundamental force, but something that actually emerges from the universe's most basic ingredient, information.
So think about it. What if time isn't this river that we're all just passively floating down? What if? What if it's something the universe is actively building right now, moment by moment? And it's building it out of the most fundamental thing there is.
So this is where we get into a brand new theory called informational physics. It comes from an independent researcher, inventor, and author named Kevin L. Brown, and his idea proposes a direct link, a really deep connection between time and information. Now, I know that sounds like something straight out of science fiction, but it's actually anchored by a surprising and very real physical law. Okay, this quote right here, it's the key. This is the whole foundation of the theory. It's a statement of fact. It's called Landauer's principle. And the amazing thing is, it's been experimentally confirmed. Get this. Every single time you erase information, we're talking even just one bit on your computer, you have to release a tiny but measurable amount of energy. That proves information isn't just some abstract idea, it's physically real. And that reality, well, that's the bridge that might let us build time itself from the ground up. So here's what we're going to cover. First, we'll look at this new answer to what time is. Then, we'll get into the physical reality of information that makes it all tick. After that, we'll see how you can actually build an informational clock, tune into a sort of universal rhythm, and, this is the big one, see how we can put this whole thing to the test. Finally, we'll talk about what it all means for, well, everything. All right, first section, a new answer to time. We're rethinking the master clock of the universe. So let's jump right in. The new proposal is called the Informational Time Index, or ITI for short. And look, this isn't just about measuring time in a new way. No, this is about redefining what time is at its most fundamental level. Next up, information's physical reality. This is all about the bridge between bits and atoms. See, to really get this new idea of time, you first have to understand this connection, this bridge between the abstract world of information, bits and bytes, and the physical world of atoms and energy. So here's that principle again, Landauer's principle. What it means is that every single time a bit of information gets erased, a tiny but very, very real puff of heat is released. There's a physical cost. And that cost is the anchor for this entire theory. Because think about it. If processing information has a real tangible effect on the universe, then maybe, just maybe, the rate at which that information gets processed is also measurable. And maybe we measure it as time. Okay, so now we're going to talk about building an informational clock, how all this information flow actually becomes a tick-tock. So the question is, how do you get from this information energy link to an actual clock? Well, if every change in information has a physical cost, then the rate of those changes, the number of changes per second, could actually be the universe's own heartbeat, its own tick-tock. So here's the core claim of the theory. It says that the passage of time is what's called a phase rate. Don't worry about the term. Just picture the hand on a clock sweeping around the dial. That's a phase. So we aren't measuring seconds directly. Instead, we're measuring how fast that imaginary clock hand is moving. And that speed, that is the rate of time. And it's driven by the flow of information. So what makes that clock hand speed up or slow down? Simple, the flow of information. The more information that's being processed, you can think of it like a higher bit rate on your internet connection, the faster that phase hand sweeps around the circle. And that means time itself is passing faster in that system. But okay, to make this actually work, you need some kind of conversion factor, right? You need a universal gear that connects the flow of information, which we measure in bits per second, to the passage of time, which we measure in seconds. And believe it or not, the theory proposes exactly that. It's a new fundamental constant called the information time constant. And it's not just pulled out of thin air. It's derived from physics we already know. It's the piece that bridges the gap. Now we get to the universal rhythm, and this is where it gets really fascinating. The theory doesn't just stop there. It suggests that the flow of time isn't perfectly smooth and constant. Instead, there's a subtle pulse, a kind of cosmic rhythm that's modulating the whole thing. This rhythm is supposedly coming from a framework that the author Kevin Brown calls triune harmonic dynamics, or THD. The basic idea is that the universe has this underlying harmonic code, kind of like a hidden musical scale that everything is built on.
And when it comes to time, this means the flow isn't perfectly even. It has this tiny but totally predictable wobble to it. And this wobble has very specific peaks at frequencies of 3, 6, and 9. Now, that is a very specific prediction. And specific predictions are great because they're exactly what you need to test a theory.
Which brings us to putting time to the test. We're moving from a radical idea to a falsifiable experiment. And yeah, that's what makes this a real scientific theory and not just some cool philosophical idea. It makes clear, testable predictions. So the big question is, how would you actually go about looking for this informational time? Well, the proposed experiment is, as you can imagine, incredibly precise. It's called phase rate interferometry. It would use two groups of entangled photons. You know, those are particles that are linked together in this spooky way where they act like a single system no matter how far apart they are. So the idea is you create two of these entangled systems, and then you compare their informational clocks side by side. By doing that, scientists could look for those tiny, predicted wobbles in the flow of time. And the level of precision we're talking about here is just staggering. Seriously. The prediction is that this method would have a stability that's competitive with the world's best atomic clocks. We're talking about being able to measure deviations down to the attosecond level. I mean, what even is that? It's a billionth of a second. It's an almost unimaginable level of precision.
So let's just put this all side by side to make it super clear. On one hand, you have standard time. What does it measure? The physical vibrations of an atom. Its foundation? Quantum mechanics. The standard is the second. Okay. On the other hand, you have this new informational time. What does it measure? The flow of information itself. Its foundation is information dynamics. The standard would be the Informational Time Index, or ITI. This is a complete fundamental shift in what we think of as the master clock of the universe.
Now, this is absolutely crucial. A good scientific theory has to be falsifiable. That means you have to know exactly how to prove it wrong. And the author lays out 3 crystal clear ways this theory could fail. Step 1. The calibration fails. If the clock doesn't measure an ITI of exactly 1 under perfect reference conditions, the theory's out. Step 2. Those harmonic peaks vanish. If an experiment looks for those specific wobbles at frequencies of 3, 6, and 9 and doesn't find them, theory's wrong. And step 3, the temperature scaling fails. The theory predicts the time constant changes with temperature in a specific way. If it doesn't, you get the picture. If any one of these things happens, the whole theory is busted.
And right here, this quote says it all. The ITI model is rejected if any of these criteria holds true. This right here is the hallmark of honest-to-goodness science. It's not about trying to be right no matter what. It's about being testable. The theory literally lays out its own execution order, basically daring the scientific community to come and try to break it.
Okay, let's zoom out. A new fabric of reality. What does this mean for, well, everything? So let's take a step back for a second. If this theory actually holds up to testing, what does that mean for how we understand the universe? The implications are, yeah, they're pretty profound. So here's the big takeaway. If this is right, time isn't some fundamental dimension we live in. It's fundamentally the measurable rate of informational change. It would unify how we think about time with information and entropy. It provides a real, testable bridge between thermodynamics and relativity. And maybe most mind-blowing of all, it suggests that the universe's evolution is literally driven by information processing. The whole cosmos could be one giant computer, and time is just the clock speed. And that leaves us with one last truly mind-bending question to chew on. If information really is the source of time, if the flow of time is the flow of information, then what does that mean for the ultimate story of the universe? Is our reality just the output of some grand cosmic calculation? Is everything around us being computed into existence, one informational tick at a time? It's a question that, if answered, could absolutely change everything we think we know.